To convert from fractions to a decimal, this is actually pretty simple. All we have to do is divide, do the division itself. So in the first problem here, 43 over 22, we're just going to take 43 and divide it by 22. Putting this into a calculator, we get 1.95 4545, and it continues on indefinitely. That means that we actually have the same thing as 1.954 repeating. The 54 repeats indefinitely. Alternatively, if we do 43 over 20, we get 2.15. And actually, if you do it on a calculator, it'll just write it as 2.15. What this means is that we have 2.150000, and the 0 repeats indefinitely. If all we have is a bunch of zeros, we just drop those zeros. Unless, of course, we're talking about rounding to certain places and error measurements, then we have more zeros than we need sometimes. But we see we have two cases here. And whenever we divide out a fraction, a proper or an improper fraction, we'll either have one of these two cases: a repeating decimal, like the top one here, or a terminating decimal, as the bottom. You will never have what pi does, what the golden ratio does, what the number E, or Euler's number does, where it continues indefinitely and never repeats. Those are called irrational numbers, and they will never be written as these fractions are, which is a whole number over a whole number. And yeah, so you'll never have that case. So that's how you convert between a fraction to a decimal. I should say there are easy fractions to convert to a decimal. These fractions are always over powers of 10. So for instance, 13 over 100, we count how many zeros are in the denominator, and we move the numerator's decimal, which is always going to be on the end, over that many places. So this becomes a 0.13. If we had 65 over 10, we move it one place because there's one zero in the denominator, and that gives us 6.5. If we have 4 over 10,000, this has 1, 2, 3, 4 places. So we move the decimal 4 times. 1, 2, 3, 4, and add zeros in the slots that remain. 1, 2, 3, with the 4 right there. I always add a 0 in front of the decimal point if there's no full portion there. I think it's easier to read and just understand that we're talking about a number like that. So whenever you're dividing by a power of 10, as 100, 10, and 10,000 are, all you have to do is move the decimal point over that many slots, and there you have a decimal number. Now, to convert from a decimal to a fraction, this is typically easy to do when you have a terminating decimal. When you have a repeating fraction, or sorry, a repeating decimal like this top one here, this is a little bit harder. It's more involved. So we're not going to worry about that right now. But for a terminating decimal, it's not too hard to do. There are a couple steps we have to do. So for instance, let's say we had 0.26. Now, to make this into a fraction, the first thing we do is we move the decimal point to the very end of the number. So we have 1, 2 places. Okay, then we put the number that we now have on top, and we put a power of 10 with the number of zeros of how many spaces we moved. We moved it 2 places. So we have a 1 with 2 zeros. If we moved it 5 places, we have a 1 with 5 zeros, and so on and so forth like that. The last step is to reduce. We always need to reduce. This isn't too hard because 100 or 1,000 or 10,000 or any power of 10 can only be divided by 10, 2, 5, and powers of 10 itself. So those are really all you have to worry about dividing by. In this case, we can divide top and bottom by 2. That gives us 13 over 50. 50 can only be divided evenly by 10, 5, 2, 25. 25 is just 5 times 5. And then, of course, 50. 13 is prime. It can only be divided by 1 and 13. So that's completely reduced. And this is the way you would write 0.26 as a fraction. Get it over a power of 10 and then reduce the fraction. That being said, whenever we have problems that have both fractions and decimals in it, we need to convert to either one or the other. We don't really ever have fractions and decimals in the same type of problem. For instance, let's say if we had 1/5 plus 1.57. The first thing I'm going to do is convert this to a decimal. So 1/5, we can do 1 divided by 5 in a calculator. What you'll see is we get 0.2. And now we directly know how to do this. We just put the decimal points in the same spot, and we get 1.77. Right, you just do 0.20 plus 1.57. That gives you 1.77. Okay, next one. Let's do 1 and 3/16 minus 0.4194. This one's even more important to change to a decimal because when you have a mixed number, that's even worse to work with. That's fine. The 1 is just adding on to the, you can think of the 1 and 3/16 as 1 plus 3/16. So really we're trying to figure out what is 3/16 as a fraction. Plug it into your calculator or do the division by hand if you want. And you get 0.1875. This is going to be 1 plus 0.1875, which gives us 1.1875 minus 0.4194. We can do the subtraction by hand. Just make sure you line up the decimals. .4194 gives us 0.7681. One and 3/25 times 2.08. Again, let's get decimal numbers first. 3/25. I'm not sure. Okay, 0.12. So this is just 0.12, and then we have a 1 on top of it. So it's going to be 1.12 times 2.08, 2.3296. Finally, we have 3.72 divided by 1 1/4. A quarter is pretty easy to know the decimal portion. It's 2.5. It's like, a quarter of a dollar. A quarter itself is 25 cents, so 1/4 is 0.25. And then doing the division there, that gives us 2.976. We can, of course, convert this into a fraction. Let me show this in the very last one here. Not necessarily that you would want to, only if the problem asks you to do that. But I just want to show you that. We're going to do 1, 2, 3 spaces. So we have 1, 2, 3 zeros on the bottom. And then divide. I'm going to divide by 2. See what we get. We can divide by 2 again. Divide by 2 again. I'm going to write it down here on the bottom. 372 over 125. 125 cannot be divided by 2. It can only be divided by 5. And 372 cannot be divided by 5. So this is completely reduced as an improper fraction. We could write this as a mixed number by asking how many times can 125 go into 372? Going over twice. 2 times 125 is 250. Then we take that away from the 372. And that gives us 122 over 125. And 122 over 125 is completely reduced. So that would be our answer there. I don't typically like working with mixed numbers because they are harder to work with in mathematics, but they can be easier to understand when you're doing application type problems. But if all you're trying to do is get final answer, then I would leave it as an improper fraction. I think that's faster and easier to work with. If a roofer lays 10.5 squares of shingles in 4.5 days, how many squares does he do in 1 day? To find this, all we have to do is divide. Ten and a half is the same thing as 10.5. 1/2 is always going to be 0.5. And then 4.5 is going to be 4.5. So we just do 10.5 divided by 4.5. That gives us 2.333 repeating, or approximately, you could say approximately 2.3 squares in a day. Now what you could also do, the problem with this decimal notation is that 2.3 is only an approximation. Because it's supposed to be 2.3 repeating indefinitely, and you cannot write that. You'd be writing forever. The nice thing about leaving it as a fraction is that you actually do have an exact number. What I'm going to do is I'm going to change the 10.5 and the 4.5 to improper fractions. So we go 2 times 10 is 20. 20 plus 1 is 21. And you always leave the same denominator, which is 2. The next one is going to be 4 times 2 is 8. 8 plus 1 is 9 over 2 again. That was the denominator that we had. Now, a division by a fraction is the same thing as a multiplication by a division. Sorry, multiplication by the reciprocal. And we can cross cancel here. 2 divided by 2 is 1. And then 3 can go into 9 3 times. 3 can go into 21 7 times. And doing multiplication straight across, 7 times 1 is 7. 1 times 3 is 3. And so here we have 7/3. 7/3 is the exact same thing as 2.3333 repeating. But 7/3 is the exact number as 2.33333 repeating. It's just a little bit harder to understand what does 7/3 mean for this type of problem. The frequency of a waveform, which is just like the wave of electricity using the AC current, is a reciprocal of the period. If the period of a device is 40 milliseconds, calculate the frequency as a decimal numeral. That's going to be in kilohertz. If you don't know, most like electricity that we use in a lot of things is using AC current. Sometimes it's DC, but AC current goes like this, and peak to peak or trough to trough or similar point to similar point, whatever that is, as long as you're doing kind of the same thing, is called the period. It's the measurement of time from the top of the peak to the top of the next peak. And then frequency is the reciprocal of the period. And this is using the reciprocal. If the period is in seconds, then the frequency will be in the reciprocal of seconds, which is kind of a weird unit, but we call it a hertz, Hertz. And so in this case, we have milliseconds, and because we have a different measurement from seconds, we have kilohertz for the frequency. There's a lot of cool things about electricity and these types of topics. You'd have to learn trigonometry to do a lot more in this. But for this problem, it's quite simple, because all we have is the period is 40 milliseconds. It wants us to find the frequency, which is going to be the reciprocal of 40, or in other words, 1 over 40. Plugging that into a calculator gives us 0.25, or sorry, I should say 0.025. And it gave us that it was in kilohertz, which is the decimal notation for that frequency of 1 over 40.